Both the offensive and defensive sides of this war routinely fly at extremely low altitudes in the war zone above Ukraine. If you fly too high, a missile will undoubtedly bring you down. Fly too low and you could make it, but the chance of striking a tree, electricity lines, or even a truck means you'll likely meet the same fate as being hit by a missile. Many pilots on both sides of the conflict refer to their sorties as suicide missions since it's a difficult decision. Yet flying under the radar is not the same as flying low. During the Cold War, fast jets were able to fly below 250 feet and mostly dodge hostile radar sweeps. The phrase flying under the radar is actually a relic from a time when radars preferred to scan the landscape at an angle upward because they were ineffective at scanning it horizontally, allowing aircraft to fly below the angle of the radar scan. But that's not the case now. Therefore, why do Russian and Ukrainian aircraft continue to fly at such low altitudes? We'll go over the 4 primary causes, but it's not true that in 1960, Americans mistook the moon for a missile threat. Radars work on a very basic principle. An electromagnetic beam of energy is narrowly blasted out by a transmitter. Some of the beam's energy is reflected back to the radar when it strikes a reflective object. A receiver picks up these echoes, and after some processing, the result is shown as a blip on the radar screen. Once a target has been located, the pertinent data can be transmitted to an anti-air system, which will then be able to fire missiles. By utilizing defenses, the pilot may avoid being struck, but the missile usually prevails. Visually verified information indicates that, as of November 2022, Ukraine has lost 50 combat aircraft and 22 helicopters, compared to Russia's 62 aircraft and 55 helicopters. Nebo-M, which handles target acquisition for the Russian surface-to-air batteries such as S-300, S-400 Pantsir, and others, is the best mobile radar system in the Russian military. Radar is capable of detecting targets up to 372 miles away in ideal circumstances, but in real life, performance can be significantly hindered by the following 4 reasons. Most radars are line-of-sight devices, much like a flashlight. Radars are unable to see past the curvature of the Earth, just like a flashlight's beam cannot penetrate corners. Since the radar requires a clear line of sight to the target, obstructions prevent the object from receiving the electromagnetic pulse, which prevents the detection of an echo. Radars, however, have a very long range of vision if there is a clean line of sight. You ask how far? Let's just say that in 1960, 2 days after the ballistic missile early warning system had been put into action in the US, there was a warning that a missile was headed in the direction of the country. But it soon became clear that the concern was unfounded. An object that was 250,000 miles away had been incorrectly classified as a threat by the radars. Across the horizon, it was the moon rising. The detection range of most mobile radars, like the Russian Nebo-M, is dependent on 2 variables: the elevation of the radar antenna and the altitude of the aircraft. Most mobile radars cannot see over the horizon. The radar's horizon range, for instance, would be 17 miles if its antenna was 16 feet above the ground and the aircraft was flying at 100 feet in the air. Yet, if the same plane flies at 33,000 feet, the radar can spot it from 227 miles away. This is why installing radars on elevated territory, such as a hill, makes sense because it extends the range of low-flying aircraft that can be detected. The drawback is that it makes the radar a simple missile target. I should point out that there are also over-the-horizon radar systems, which are larger radars that can see beyond the horizon, but they remain immobile owing to their size. As they cannot communicate with anti-air batteries on the ground, they become less important to the battle on the battlefield. Not yet, at least. Terrain is the second consideration. Both a valley and a hill can physically conceal an aeroplane from radars. Getting underneath a building or tree line can also work. In truth, the Ukrainian Air Force used the terrain to its advantage in April 2022 to resupply and transfer wounded men from Azovstal and Mariupol, the city that was totally surrounded by Russian forces. To escape radar detection, Ukrainian helicopters took advantage of the terrain. However, after carrying out a couple of these flights, the Russians saw a problem and moved their radars, allowing them to take out a number of Ukrainian helicopters. Kyiv was forced to suspend the helicopter runs because it had no other option. The third is radar clutter, which might take the shape of ground clutter or atmospheric junk. Radar electromagnetic emissions can be affected by rain, smoke, dust, clouds, birds, water vapor, and other elements in the atmosphere. As a result, the radar's effective range may be drastically reduced, which will make it more difficult to detect aeroplanes over background noise. The problem with air sludge gets worse. the further the target is from the radar station. Then there is ground clutter, a phenomena where things on the ground like trees, buildings, and power lines reflect back the radar signal. Because of this, it may be challenging for radars, both on the ground and in the air, to distinguish between a low-flying aircraft and all the noise reflecting back from the ground. But this problem has been mostly rectified by current Doppler and look-down shoot-down radars. Newer radars have the ability to ignore fixed targets and concentrate on moving ones. Low-flying aircraft can still get lost in the chaos and become invisible. This type of flight, known as nap of the Earth flight, involves a helicopter or fixed-wing aircraft flying at a very low altitude to blend in with the ground clutter and obstruct radar signals from both airborne and ground-based sources. Helicopters can fly as low as 10 feet above the ground during nap of the Earth flights, whereas jets can only fly as low as 50 feet. Because of their significantly higher speed, both Ukrainian and Russian pilots employ the method of popping up to attack as soon as the aircraft reaches the objective and turning back before the adversary can even retaliate. In particular, helicopters, which can fly lower and slower, can aid to blend in with moving automobiles by flying over roads and highways. Although low-flying aircraft may potentially be detected over highways by aerial radars, it would be too risky for Russia or anyone else to regularly deploy such precious resources close to a conflict zone. A low-flying aircraft, though, wouldn't be a simple target for Mampids. Nevertheless, only if you can clearly see the aeroplane. High-speed, low-flying aircraft don't allow Mampids operators much of a chance to respond. In a few seconds, it would come over the horizon and then vanish. Having said that, if you fly too slowly and at a high altitude, Mampids will find you easily. To take advantage of multipath interference, aircraft fly extremely low in combat zones for the fourth reason. The returning signal may take 1, 2, or more routes to the receiving antenna, even if the radar signal bounces off the aircraft. This is due to the possibility that the signal's return path could include bounces off of the ground, bodies of water, or other objects. It can be challenging for radar operators to distinguish between which blip on the radar screen is the real target when the same signal is received over several different paths and produces ghost targets that behave and appear identical to the genuine target. The genuine target, for instance, can appear as one of 3 moving blips that the radar detects at 3 distinct elevations. The likelihood of the jet being shot down was decreased as a result, as long-range radars can quickly identify the target, and anti-air missile systems, like the S-300, can shoot it down from 90 miles away. We determined early on that flying high in a war zone is a suicide mission. Yet, this does not imply that flying very near to the ground is risk-free. The ground's obstructions, which can range from trees to power lines, can be very dangerous, especially when things like power lines are difficult to see. These power lines' routes are occasionally plotted on specialized maps, although their accuracy is sometimes in doubt, particularly when they are in another nation. Because of this, nap of the Earth flights are typically made during the day, when visibility is at its best. But, with the aid of the night vision goggles, they do occur at night as well. Although the precise number of crashes attributable to flying too low is unknown, they have affected pilots from both Russia and Ukraine.